we've got another example here of determining the end behavior of a rational function. This time, though, the biggest power overall is the fifth power, and that appears on top. The biggest power on bottom is 2. Now, that's the one we care about. 2 is the biggest power on bottom. Now, it's not absolutely necessary that you write that every time. I've been writing that because this is a new idea and a new strategy, and I want to emphasize that it's the bottom power that we care about. This is the example where we're going to see why that's the case. Okay. So what I'm going to do is I'm going to work through this once using 2, using the biggest power that's on the bottom. We'll get the right answer. Then we'll try this problem again, but using 5 instead, using the biggest power on top, and we'll see what goes wrong. And then we'll understand why I've been emphasizing that we want to use the biggest power on bottom. All right, so for end behavior, and again, it is very important that this is end behavior, not limit at a finite number. For end behavior of a rational function, the trick is to multiply by 1 in the form of the reciprocal of the biggest power on bottom over itself. Distributing that, we get the limit as x goes to negative infinity. X to the 5th over x squared plus 2x to the 4th over x squared plus 3 over x squared all over 2x squared over x squared plus 1 over x squared. Now, in some of those terms, we can cancel some x's. So we've got the limit as x goes to negative infinity of. My first fraction on top becomes x cubed. The second fraction on top becomes 2x squared. The third one stays as 3 over x squared. First fraction on bottom reduces to 2. Second one stays as 1 over x squared. Now, I know that all the pieces that still have x's on the bottom are going to be going to 0, because as x, and therefore x squared, get big, their reciprocals go to 0. I can see that on bottom, this piece is fixed at 2. Okay. So the bottom's going to 2 plus 0. The bottom is going to 2. Now on top, I have 2 pieces that still have x's on top. These pieces are going to be going off to infinity or minus infinity. It's not helpful to evaluate them individually. X is going to negative infinity, so x cubed is going to go to negative infinity. 2x squared is going to go to positive infinity. Quote unquote negative infinity plus infinity doesn't make sense. But I can evaluate these pieces together. That is a polynomial. The pieces, just looking at the pieces that have x's left over on top, that's a polynomial that's going to be dominated by its lead term, which is x cubed. That's an odd power. We're going to negative infinity. So the top is going to negative infinity. At least this piece is. This piece is going to 0, so that's not going to change it. While I can't literally write negative infinity plus 0, I can think through that. I've got something that's big and negative. I'm going to add something that's close to 0 to it. I'm still going to have something big and negative. Now I'm dividing that by something that's going to 2. Okay. What I'm concerned about there is the fact that that is positive. This is huge. Dividing by 2 isn't going to change the fact that it's huge. It's going to be half as huge, but it's still going to be huge. What I'm concerned about is, does the sign change? And if the bottom is going to positive 2, the sign does not change. And so this is going to negative infinity. Okay, that worked out nicely. Okay. Let's take a look at what would happen if I had tried to use x to the 5th instead of x squared. Okay. So it would still be legal to multiply by 1 in the form of 1 over x to the 5th over 1 over x to the 5th. It's not that I can't do that. It's that it's going to prove to not be helpful. This becomes the limit as x goes to negative infinity of x to the 5th over x to the 5th plus 2x to the 4th over x to the 5th plus 3 over x to the fifth, all over 2x squared over x to the fifth plus 1 over x to the fifth. So canceling the x's where I can, we've got the limit as x goes to negative infinity of 1 plus 2 over x plus 3 over x to the fifth over 2 over x cubed plus 1 over x to the fifth. Now, every piece that has x's on the bottom is going to be going to 0. And that's the problem. Because every piece on bottom went to 0, so that the bottom as a whole is going to 0. Now the top is going to 1. So we've got a situation where the bottom's going to 0 and the top isn't. I do know something about that. I know that that means that this fraction is getting really, really big. It's not going to be a vertical asymptote simply because we're not approaching a finite number, but this limit has to be either infinity or negative infinity, or if somehow I didn't get a consistent sign, not exist. With a rational function, I'm always going to get a consistent sign, but I don't have information to tell me what sign that is. The bottom is close to 0. You can be close to 0 and be either positive or negative, but I've lost all information about whether the bottom was positive or negative by making it go to 0. So that's why I want to avoid using the biggest power on top unless it happens to agree with the biggest power on bottom. If I multiply by the reciprocal of the biggest power on bottom, that ensures that the lead term on bottom, when I multiply by the reciprocal of the power, becomes a finite non-zero number. That's going to be either a positive number or a negative number. I'm going to still have information about the sign of that. If all I know is that the bottom is going to 0, I can tell that this fraction is going to be going off to infinity or negative infinity, but I don't know which one. So that's why I want to use the biggest power on bottom rather than the biggest power on top. Okay, excellent. So we got, when we used the biggest power on bottom, we got negative infinity, if you remember. Let's actually just take a look real quickly and check our work by using the shortcut. Limit as x goes to negative infinity, if I just take the fraction of the lead terms, this becomes the limit as x goes to negative infinity, x cubed over 2. X cubed is going to be going off to negative infinity. Dividing by a positive number, it's still going to be big, and that won't change the sign, so we get negative infinity. Nice to see. And essentially the work of multiplying by 1 in the form of 1 over x squared over 1 over x squared justified our just looking at these pieces. Because if you remember, on bottom we had one piece that was going to 2, and the other piece was going to 0, so we got to ignore it. On top, when we divided through by x squared, this piece went to 0. These two pieces still stayed big, but these two pieces together were a polynomial, and we knew we could look at just the lead term. So the work that we're doing in multiplying by this fancy form of 1 is essentially justifying ignoring those other pieces. Do make sure that you understand, if you use this shortcut, make sure you understand why it's okay to ignore those other pieces. Because in general in math, to ignore part of a problem is usually a bad idea. Okay? If you can justify ignoring those pieces because compared to the lead terms on top and bottom, they're very, very small, then this is a really nice shortcut to use. Again, do make sure that you practice showing your work because I may require that on exams and quizzes.